Okay, so for this question, we're looking at a long horizontal cylinders, the Newton number, which is correlated to the Reynolds and Prandtl number. So we start by importing our Python packages. And then these are the given values that I typed in ahead of time that are given to us in the equation. And these are the values a part of our Newton number equation. So first thing we want to do is have create logarithmically spaced Reynolds and Prandtl number values. So and we want 50 of those values. So I'm going to say n is equal to 50. And then this part here helps us choose the set of random numbers so that we can have them compare. Randoms. So the Reynolds number, just regularly spaced, we just want the Reynolds number is a random value of our set of values, which are logarithmically spaced from 10 to the negative 4 to 10 to the 10. And then the same for the Prandtl number. But Prandtl number, we go from 10 to the negative 1 to 10 to the 4th. And we want this at the size of 50. We want 50 of those values, so we're going to equal our value n. So now we want to generate our Newsel data from our random pairs of Reynolds and Prandtl numbers. So we're going to say that our Newsel data is C1. And this is just entering from the equation we were given in the problem. And we want this data to have some error value to it. So we are multiplying this by a random error with an average of 1 and a standard deviation of 2%. Okay, make sure we have no problems. Okay. And now we're going to minimize the relative mean square error between the model data and the synthetic data. So the data with our variation and then what we would expect it to be. So we're going to define in the function mean weighted square error. And that we have a value of A, B, C, D, and then C1, C2, C3, which are all parts of our V value, or variable. And within that, we have our model function, which we are trying to minimize. So we can actually just copy and paste that from up here. So after that, we want to return the average, so the mean of the difference in our model versus our generated data divided by our data. Again, so that we're looking at the error between the two, and it doesn't matter if it's positive or negative because we're squaring it as well. Okay, so now we want to minimize our mean weighted square error equation. So we say res equals minimize mean weighted square error. And we'll have to make a guess. So our guess will be the values that we had given in the equation in the question already, which was A, B, C, D, C1, C2, C3, which were defined earlier. And then we can print that. So we get a value of A, B, C, D, and then C1, C2, C3. So our coefficients here. So we can compare that to our the values that we were given, and we can see how these are now slightly adjusted with our 2% error of Nusselt number data. Now they're slightly adjusted from our given A, B, C, D, C1, C2, C3 values. So these coefficients here have been adjusted to the data that we collected, that we synthesized, and we can compare it to the equation givens that were given to just general data. So that's how we fit our non-dimensionalized data for this question.